Okay, I don't know what that was. This is going to be a combo video lesson. The first lesson will be lesson 6-2, and then the second set of slides will be lesson 6-3. And the reason for that is, well, you'll see, they're like, once you learn how to do these one-step addition equations that we're going to do first, the next lesson is basically you'll be doing the opposite, and it is very simple once you understand the first one. So let's get started with one-step addition equations. You are going to use the subtraction property of equality to write and solve one-step addition equations. So yes, you read that correctly. You're going to be using subtraction to solve addition problems. And it'll make sense, I promise. So first, we have to write addition equations. You can write equations to represent many real-world problems involving addition. The table below shows the steps for writing an equation to represent a real-world problem. So here are the steps. Here's the words first. Describe the mathematics of the problem. Use only the most important words in the problem. Then you need to define a variable to represent the unknown quantity. And then finally, you can translate the words into an algebraic equation. This is similar to what we've done before, where we've made algebraic expressions, but this time we are making an equation, which means it will have an equal sign and they will be solvable. So describing the quantity that a variable represents and selecting a letter to represent that unknown quantity is called defining the variable. We've defined variables before. It just means that you're picking a letter to represent the quantity. All right, here is what we're gonna do. In a recent Summer Olympics, the United States won 23 more medals in swimming than Australia. The United States won a total of 33 swimming medals. Write an addition equation that can be used to determine the number of medals won by Australia. So we're going to first do the words. So medals for Australia plus 23 equals 33 medals for the US. So remember, we just pulled out the most important stuff from that paragraph word problem that they gave us. Then we're going to define a variable. We can let M represent the number of medals for Australia, M for medals. And then that equation, when we write it out, looks like this. M plus 23 equals 33. So medals for Australia, M, plus 23, 23 equals, and then 33 medals for the US. So it's a lot, it almost looks even simpler in this form than the words. Definitely looks easier than that paragraph we had. All right, so here's an example, another one. We are going to write more addition equations. Together, Ruben and Tarek downloaded 245.5 megabytes MB of music. Ruben downloaded 132 megabytes of that total. Write an addition equation that can be used to find how many megabytes of music Tarek downloaded. What is the unknown in this problem? Well, it is how many megabytes of music Tarek downloaded. So here is how to describe it in words. Ruben and Tarek downloaded a total of 245.5 megabytes of music. Of this total, Ruben downloaded 132. Let's define variable. Looks like we're going to use M again. M stands for megabytes in this case. And that is representing the megabytes that Tarek downloaded. And then we can write the equation. So the equation is going to be 132, that's Ruben's, plus M, which is Tarek's, and the equals 245. It's actually 245.5, but they did some rounding here for you. You probably shouldn't round unless it tells you to, but I think they just did that for simplicity's sake here. All right, what are some other ways to write the equation based on the real world problem? So we could have written the M first and gone M plus 132. You also technically can write 245 equals 132 plus M. You can write them basically in any order as long as the things you're adding stay on the same side as each other. That will work. So you try it. You're going to try this one. It's together. Zacharias and Paz have $756.80. If Zacharias has $489.50, how much does Paz have? Write the equation that can be used to find the amount of money that belongs to Paz. You try it. All right, next we are going to learn to solve these. So we learned how to write them, now we're going to learn how to solve them. You can use substitution, models, or properties of mathematics to solve addition equations. There's a video, I'm not going to show it to you, but if you want to see it, you can go on your Reveal Math. And you can do this with tiles over here. So if we have x plus 4 equals 7, it would look like this in tile form. We have 1x plus 4 equals, and then we've got 7 little tiles here. All right, so then what we do is you isolate the variable by removing the same number of tiles from each side. So originally, remember, there were 4 ones here, and there were 7 ones over here. So they've taken away 4 from this side, and they've taken away 4 from this side so that the x is by itself. That's what it means to isolate the variable. Isolate means to make it be by itself. So now we can just see from this model that x is equal to 3, because there's 3 tiles left on this side. Another way to solve addition equation is to use inverse operations. Inverse meaning like the opposite. The operations that undo each other. So when you solve an addition equation by subtracting the same number from each side of the equation, you're using the subtraction property of equality. So that's why we're using subtraction to solve addition problems, because if we use subtraction on an addition problem, it's the inverse operation which undoes the addition that we're trying to do. So here's how it will look. If you subtract the same number from each side of an equation, the two sides remain equal. So for example, 5 equals 5. 5 minus 2 equals 5 minus 2. They're still equal, even though we're subtracting 2. But since we're subtracting from both sides, it's going to stay the same. Here's how it can look with a variable. If x plus 2 equals 3, then x plus 2 minus 2 equals 3 minus 2. And so we're subtracting 2 from each side here, which is keeping them equal because we're doing the same thing on both sides. So let's look at it a little better here. Sorry, this looks bad on the slides. You can have a follow along in your book. So let's solve this equation, x plus 4 equals 7, by using the inverse operations. You undo the addition of 4, this plus 4 right here, by subtracting 4 from each side of the equation. So we can get rid of this plus 4 and leave x by itself if we subtract 4, because those are opposite operations, inverse operations. So we write the equation out. X plus 4 equals 7. Then we can subtract 4 from both sides. X plus 4 minus 4 is just x. 7 minus 4 is 3. So the solution is x equals 3. Let's try this again in another example. If we have 8 equals x plus 3, we can figure out what x is. You can use the model. So we have our 8 over here, and we have our x plus 3 on the right side. And then if you take away the 3 from the right side, you have to also take away 3 from this left side. 8 minus 3 is going to be 5, which means x equals 5. Or you can do it with the subtraction property here, which is pretty much the same, it's just not as visual. So we've got 8 equals x plus 3. We're going to subtract 3, and we know to subtract 3 because that's the one that's on the side with the x. It's on the same side as the x, because we want to get rid of that number here so that we can leave x by itself. So 3 minus 3 is 0, so we're left with just x. And then on this side, 8 minus 3 is 5. So 5 is what x equals. Right? You also could use a bar diagram if you really like this visual representation. You would have to put your tile to be x and then another tile to be 3 here, and this whole thing together equals 8, and that is from the original equation. The total length of the bar represents 8, which represents the value of the equation. What is the value of x? And so what they would have you do here, is divide this into 8 equal sections. You'll have your 3 here, and then you'll see that there would be 5 here. Not sure why they didn't divide those into sections for you. You could use the bar diagram. This is going to be the one, the subtraction property of equality. This is going to be the one that you'll want to use the most likely, because it will apply to much more advanced equations that you'll be working with. All right, so then try this one. 570 equals 33 plus x. And when it says 4x, that means you're trying to solve what x is. You can use any of the methods, but like I said, I recommend trying the subtraction property one. All right, and then we've got another example here, this time using some fractions, but it works the same way. So we've got 3 3/4 plus m equals 7.5. They're going to show us how to check the solution as well. So sorry, these are written super bad, and especially this one. So we've got 3 3/4 plus m equals 7.5. That's where that gave us that in the beginning. If we want to rewrite this so we can actually add with fractions, we should use like denominators. So this should say 3 3/4 plus m equals 7 2/4. Sorry, it's not 72 divided by 4. I don't know what happened there. It's 7 2/4, which is the same as 7.5. Then we can subtract 3 3/4 from both sides to isolate our m, our variable on this side. And so when you do that subtraction, you get 3 minus 3/4. 3 3/4 minus 3 3/4 is 0, so we have m left over. And we have 7 2/4 minus 3 3/4 is going to be 3 3/4. So m is equal to 3 3/4. You can check your solution by plugging in that value for m. So if we got 3 3/4 for m, we should be able to add this now, like plug it in, substitute it in here, and it should equal out to 7.5 if we're correct. And in this case, we were. All right, so you try it. It's just with fractions this time. It's the same method. Otherwise, you're going to want to get some common denominators here. So probably switch this 4 up to an 8. So you'll need to do some math there. But go ahead and try that check. And that's the end of lesson 6.2. And then 6.3 is one-step subtraction equations, which are, this is going to be exactly the same, except instead you're going to be using the addition property of equality to write and solve these. And so you'll be doing the exact same thing, only instead of subtracting, you'll be adding. It's literally the same otherwise. So we already talked about this. This is exactly the same as before. It's just a reminder. Then here is our first example here. If Caroline gave Everly 8 beads and was left with 37 beads, you can write a subtraction equation that can be used to determine the total number of beads Caroline had originally. One catch here with subtraction is you need to make sure you put the right number first, because you can't subtract in both orders. You can only subtract in one order, from left to right. So you need to make sure that you put your subtraction in the right spot. So in this case, the total number of beads minus the number of beads given away is going to equal the number remaining. So we can say T for the total number of beads, because that's the part we don't know. So T minus 8, which is how many she gave away, equals 37. So this is what I mean by being careful. You can't put 8 minus T. That will not be the same thing. So you need to make sure you put things in the right order depending on the words. Okay. The oldest person to travel in space was John Glenn. The youngest person to fly in space was only 25 years old. At 25 years old, this is 52 years less than John Glenn's age. So we're going to write a subtraction equation that can be used to find his age when he traveled in space. So 52 years less than John Glenn's age is the youngest person's age. We're going to say A for age of John Glenn specifically, and we can write our equation. So we don't know the age, so that's A, minus 52. So whatever the age is, 52 years less than that is 25. Okay, so we know that this is the youngest person, and there's like that 52-year difference in between them. And so what is John Glenn's age? That would be A. Try this out. This is not solving yet, by the way. This is just writing the equation. So try your check. And then here's how you solve them. It's like I said, basically the same as the addition problems, but we're just going to do the opposite here. So you can still use substitution models or properties of mathematics to do these. Here's how you could represent it in a bar diagram. If you have x minus 15 equals 11, we don't know x, so here's our x here. X minus 15 equals 11, and so then you would want to figure out the total here to see what x was. Okay, so because x represents the length of the entire bar, 15 plus 11 is going to equal 26, which is our x. Let's look at this with addition property of equality. If you add the same number to each side of an equation, the two sides remain equal. This is exactly the same as if you subtract. So if you have 10 equals 10, that's the same, 10 plus 3 equals 10 plus 3. If n minus 6 equals 7, then n minus 6 plus 6 equals 7 plus 6. So in this case, we're just adding 6 to both sides to get that equality to stay the same. So here's how we can do this with an example. 13 equals x minus 7. Whoa. Whoa. Okay, sorry. So why is this different? 13 equals x minus 7. Okay, I guess they changed it. 32 equals x minus 7. We're going to do 32 minus equals x minus 7. To get x by itself, or to isolate x, we want to get rid of this minus 7. To do that, we do a plus 7. If we do a plus 7 on the right, we need to also do a plus 7 on the left. So x minus 7 plus 7 is x, because that cancels out our 7s. And then 32 plus 7 equals 39. So the solution of the equation is 39. And again, if you want to check that solution, all you got to do is take the solution you got, plug it in for x, substitute it in for x, and check and see if it works. 39 minus 7 is in fact 32, so it is true. Here's your chance to try it out. And then there's another version here with fractions again. This is in your book. I don't really know. I actually don't even really want to go over this example. You do it the same way. You want to make sure that this the denominators are common, and then you add on both sides, and then you should end up with the solution of 15 and 5/6. Sorry, I don't know what's going on with the slides. It's glitching out. But that is the end. So, like I said, if you do one thing on one side, such as subtracting to isolate a variable, you need to do that on the other side of the equal sign as well. If you are doing an addition equation, you want to subtract to get rid of, because it undoes that addition, and you do the opposite for a subtraction problem. So you just want to pay attention to what kind of problem it is, and then do whatever is going to isolate the variable. And that's it. You can do it all.